Okay, so we're going to prove that if x is not in B and A is a subset of B, then x is not in A. Okay, so let's go ahead and draw a picture to showcase what's going on here. So we have B and A, right? So if x is not in B, right, and A is a subset of B, which is what we have going on here, then x can't be in A, right? Because x can't be anywhere in B, right? So anywhere in this area, it cannot be. So of course, if it can't be anywhere in this area, then most certainly it can't be in this little piece of B, right? Which is A. Okay, so that is the idea. All right, so let's go ahead and start the proof. So we're going to do this by contradiction. So remember, this is of the form P implies Q. So by contradiction, we want to assume the negation of this and arrive at a contradiction. And of course, this is logically equivalent to P and not Q. So we're going to assume P and not Q and arrive at a contradiction. Okay, so we're going to assume. So P is x is not in B, and A is a subset of B, right? And we're going to assume not Q. So not Q would be x is in A, because Q is x is not in A. So the negation of Q would be x is in A. Well, we know if A is a subset of B, this implies that for every x, if x is in A, this implies that x is in B. Well, we have x is in A. So for all x, if x is in A, then x is in B. So this implies that x is in B. But look at our contradiction. We assumed that x was not in B, and we arrived to x was in B, right? If we assumed that x was in A, we arrived at it must be in B, right? But we assumed x was not in B. And this is our contradiction. And that's the proof.